Good day, everyone. So today we're going to be taking a look at May-June 2019 exams, additional maths. So let's get started. So for those who know, we are already given a formula sheet, right? So you could take a look at these formulae and use it in the relevant sections. So let's start. So we have number one tells us the function f is such that f of x is equal to 2x cubed plus 7x squared plus 3x, determine all the linear factors of f of x. So hence here they ask to factorize f of x completely. So notice that each term has an x in it, so we could factor that out. So we could say f of x is equal to x times 2x squared plus 7x plus 3. Notice if you multiply by x, you will regain what we originally had. Now we wish to factorize this piece because this is already linear. Okay, so recall how to factorize a quadratic. We want two numbers that when added give you 7, but when multiplied, okay, so let's do it this way. So we want AC, factors of AC when added should give you 7. So A is 2 and C is 3. So AC is 6. So notice that combination can be a 1 and a 6, because 1 plus 6, 7. So we can replace that. We have x into 2x squared plus x plus 6x plus 3. We could now factorize by grouping. Group these terms. We get x is in common. So we get 2x plus 1 plus, group these two. Notice that the HCF is 3. So we have x into 2x plus 1 and factorize like terms. So we have the 2x plus 1 here. So we have 2x plus 1 and the remaining x plus 3. And this is our linear factors. We are finished. Part 2, say compute the roots of the function f of x. So the roots occur when f of x is equal to 0. So that's f of x equals 0, which would imply that we have x times 2x plus 1 by x plus 3 equals 0. So this would mean either x equals 0, so that's our first root, because if three things or two things are multiplied or more to give you 0, that means at least one of them have to be 0. So we get either x equals 0, 2x plus 1 equals 0. So that would mean that x is equal to negative a half. Well, we could carry the 1 and divide by 2. Or x plus 3 equals 0, which would mean that x is equal to negative 3. Yes. So this is our roots of our function. X equals 0, x equals negative a half, or x equals 3. Part B, two functions are such that g of x equals x squared minus x, and h of x is equal to 2x minus 3. Determine g h of x. So that means wherever we see x in g, we're replacing it with h. So we have gh of x is equal to, now it's x squared, but we want to replace all the x's with h of x. So we have 2x minus 3 squared minus 2x minus 3. Now there's a easy way to simplify this rather than trying to square this and multiply it out and add up like terms and whatnot. What I would like to do here is factorize it. Notice that this is a common factor. So I could have 2x minus 3. And what would I have inside? I would have 2x minus 3, then minus 1. Notice, if I distribute, I'll get 2x minus 3 squared minus 2x minus 3. So therefore, we have 2x minus 3, and inside we have 2x minus 4. And now this should be fine. You could distribute it and simplify, but this is already gh of x. Given that hg of x is equal to 2x squared minus 2x minus 3, show that the values of x for which hg of x equals 0 can be expressed as 1 plus or minus root 7 over 2. So they want to show that the roots is equal to 1 plus or minus root 7 over 2. So we have to check that 2x squared minus 2x minus 3, if that is equal to 0, we could use our quadratic formula. We call the quadratic formula is equal to x. Well, x is equal to minus b plus or minus square root b squared minus 4ac all divided by 2a. So we know that the coefficient of x squared is a, the coefficient of x is b, and the constant is c. So let's see what we get. We get minus b, so that's positive 2, minus negative 2 is positive 2, plus or minus the square root b squared, negative 2 squared is 4, negative 4 by 2 is negative 8, negative 8 by 3, it is positive 28, divided by 2a is 4. Now we just need to simplify this. So we have that is equal to 2 plus or minus square root 4 plus 28, that is 32. 1 second, please. I think I made a slight arithmetic error. Negative 4 times 2 is negative 8. Right? Negative 4 times 2 is negative 8 times negative 3 is positive 24, not 28. Sorry about that. I think I was jumping ahead with adding the 4 and the 24. So 4 plus 24 is 28, all divided by 4. So notice 28 can be written as 4 times 7. So we have 2 plus or minus square root 4 times 7. So we can split it up like that, divided by 4. Simplifying, so we have 2 plus or minus 2 root 7 divided by 4. Simplifying further by factorizing a 2 out of the numerator, we get 2 into 1 plus or minus root 7 over 4. And finally, 2 into 2, 1, 2 into 4 is 2. So we get that x is equal to 1 plus or minus root 7 over 2. And hence we are done with the proof. They wanted us to show that this is the roots, or that is our values for which hg of x is equal to 0. Part C. Solve 3x log 2 plus log e to the x equal 2. Now there are a few ways of going about doing this, right? We could bring these back into the exponents. So normally when we speak about log, that is log base 10. So we have log 32 to the 3x by the log rule plus log e to the power of x, and that is equal to 2. This 2, so 2 to the 3x, is the same as 2 cubed to the power of x, where we could just multiply the powers. Right, so we could simplify this further as 8 to the power of x. So we get log 8 to the x plus log 8 to the x equal 2. Adding them, because they are the same, we get 2 log 8 to the x equal 2. So we can divide by 2 on both sides. So we get log to the 8x equal 1. So that means if we raise both sides to the 10th power, or take 10 on both sides, we get 8 to the power of x equal 10. Or simply, from right here, we could use the log rule to bring the x in front. So we get x is equal to 1 over log 8. And if you would like a numerical value, that is about or approximately 1.107, and so on. Okay, so we are finished with number 1, and let's take a look at number 2. Express f of x equal negative 2 x squared minus 7x minus 6 in the form a into x plus h squared plus k. So to do this, we could look quickly at the expanded versions in case you don't recall the formulae or the formula to solve it. Let's see if they give us it in the formula sheet. They did not, right? They did not give us how to do that. So we have to come up with a way. So what I usually do with my students is show them this way. So if we express ax squared plus bx plus c, and we want it equal to this, to a, well, we can expand this out. Notice that that is just x squared plus 2xh plus h squared, and then we have our plus k. All right, so we could simplify this. So let's just do this quickly. So we could multiply ax squared plus 2ahx plus ah squared plus k. So notice that this here, it doesn't give us any information if we compare coefficients. That is just a. So we need 2ah to be equal to b, and we need this thing here to be equal to c. All right, so the formula we get is b is equal to 2ah, so h is equal to b over 2a. C need to be equal to ah squared plus k, because that is our constant term on the right hand side. So k is equal to c minus ah squared, and that is our formula. The minimum or maximum value the minimum or maximum value occurs at minus hk. All right, so I would like you all to recall that. Very nice. So what do we get? Let's do our working right here. So we can find h right away. That is b over 2a. b is -7. So that's -7 over 2 times -2, which is +4. Sorry, -4. 2 times -2. So this is a. So what we get, these cancel, and we get 7/4. And k is equal to c minus ah squared. So we have c is -6 minus a is +4, +2, my bad, because negative is positive, and 8 squared is 49 over 16. We cancel these down back to 4. Simplifying what we have -6 plus, now we could write 6 as 24 over 4 plus 49 over 4. And when we add these two things, we get 25 over 4. So we have our h and we have our k. So f of x is equal to, now we have a is -2, so we have -2 times x plus h is 7/4, and k is given by 25/4. And this is our form. This is what we call the standard form. Or yeah. So state the maximum of f of x. Well, that is minus hk. What was h? H was 7/4. So this would be minus 7/4, comma 25/4. State the value for x for which f of x is a maximum. Well, the value for x would be that value there. That is where the maximum f of x value occur. So we have x equal -7/4. And you could verify this by placing 7/4 into f of x and working it out. And you'll notice that that is the maximum value you get. And if you go less than -7/4, you'll get something smaller. If you go more than -7/4, you get something smaller. And remember that x squared only has one turning point. Quadratic graphs only have one turning point. Cubics have at most 2, etc. So use your answer in A1 to determine all the values of x when f of x is equal to 0. So they want the roots. So we have f of x. Let's just copy this. Right, and we want the roots, so that is equal to 0. And we can move some things around. We can carry that across or subtract 25/4 from both sides and divide by -2. So we get x plus 7/4 is equal. Now, if we carry this across or subtract it from both sides, we get -25/4. And if we divide by -2, the negatives cancel to leave you with 25/8. Now, remember that dividing by 2 is the same as multiplying by a half. All right, so don't forget our squared. Let's just verify that, yes, we forgot our squared here as well. All right, so that's simplified. So we can now take square root. Now, when we take square root on both sides, remember to put plus or minus on one of these sides, because both plus, the positive version, and the negative version satisfy our equation. And if we only put the positive square root, then we are losing solutions. So put plus or minus here. Then cross out those things. So we get x plus 7/4 is equal to plus or minus root 25. It's 5/8. Now we have root 8. Now we don't like these things in the denominator. We prefer them to be in the numerator, so we can rationalize this right away. Multiply top and bottom by root 8. Right, because this is just multiplying by 1. So we have 5/8/8. And we can finally move across the 7/4. So we get that x is equal to, now we can write 7/4 as 14/8, right? Because we want to add up everything. So we have 14/8 plus, so we have minus 7/4 because we carry that across. Right, so we have plus 5/8/8. Now plus or minus, plus or minus. Right, so we have negative 14 plus or minus 5/8/8. And you would notice, or you could check, that this is the solution you would get if you use the quadratic formula. Now, can this be simplified? Yes. And how? Well, you can notice that root 8 is 4√2. All right, 4√2. We get factor out of 2, so square root of 8 is equal to 4√2. Right, root 4√2, so that is 2√2. We get factor out of 2, so we could get 2 times negative 7 plus or minus root 5√2, right? Because we already factored out the 2, divided by 8, and simplifying, we get the result. Negative 7 plus or minus 5√2/4. And that's your answer. So if you use the quadratic formula, you should be able to get this. Sketch the function f of x to show your solution set when f of x is bigger than 0. So if you were to sketch the function, our maximum occurred at negative 7/4. So negative 7/4, that's somewhere here. So this is 25/4. This is negative 7/4. And we have two roots, one at 7 minus 5√2/4. That is right here somewhere, maybe. And we have our other root at negative 7 plus √5/4. And you could check to see if that is positive or negative. Right, and that is positive. Right, a very small positive number, but it's positive nonetheless. So our graph would look something like, this is our turning point. I try to get as smooth as possible. Something like that. We could work with this. Right, and this is our roots. So we want when f of x is bigger than 0. So that's in here. Right, that is above the x equals 0. Well, sorry, the x axis. If they wanted where it's negative, that's delete here and here. Finally, we are on part B. The geometric series can be represented by y over x plus y squared over x cubed plus y cubed over x to the fifth plus dot dot dot. So notice they want us to prove that the sum to infinity is xy over x squared minus y raised to the negative 1 power. So this may be a lot to take in, but we are told that it is a geometric series. That is what we are told. So that means that it has a common ratio, and they want to get the sum to infinity. Notice the amount of marks is 4 marks. So we could find, right? So we could say recall the sum to infinity for a geometric series is equal to the first term over 1 minus the common ratio. Right, and I believe that is one of the formulae they give. So let's just verify that. The sum to infinity for, yeah, get right here. But it also has a condition that the value r is between -1 and 1, not inclusive of either side. So that means once we have our common ratio be less than 1, the absolute value, or when we take off the sign of r, the positive value is always less than 1. So we want to find out what our common ratio is. So we could find what we need to multiply by to get to this level, etc. Or we could say that this number divided by that will give us what, this number divided by that will give us what, etc. And we want to get that value to be a constant, or to check that that value is a constant. So we would notice that r here, now how do we get from y to y squared? Well, we multiply by y. And how do we get from x to x cubed? We multiply by x squared. So I conjecture that my common ratio is y over x squared. Now, if I multiply y squared over x cubed by y over x squared, I get y by y squared is y cubed, and x squared by x cubed is x to the fifth. So we get our term. So this happens to be our common ratio. So we can simplify this. So we get the sum to infinity. Now we could say, assuming that y over x squared is less than 1, right, or the absolute value of that, because that is our common ratio. Now y could be negative, so we just have to make sure and put our absolute value. The sum to infinity would be the first term, which is y over x, divided by 1 minus the common ratio, which is y over x squared. Now we can simplify this. We need to simplify this. How could we do it? Well, we could multiply the top and bottom by x squared. Right, that's the same as multiplying by 1. Why? Because I see a complex fraction in the denominator, and that is x squared. So that would help me out. So if I multiply the top by x squared, I get yx, or xy, divided by, because x squared and the x would cancel off, just leave it with x on the top. X squared by 1 is x squared minus y. And notice this is in the denominator, and this is to the power of 1. Right? So I could use exponent rules to get xy by x squared minus y, and then I have -1. Let's see if that is what we want to prove. Yes, that is what they wanted us to prove. So we could say, hence proven. All right, so that means if you could figure out any series, right, the sum of the series for certain values of x and y, once you have y divided by x squared is less than 1. Right, so y could be 1, x squared could be perhaps 9, so x is 3. Right, so you could get 1/9, and you could just substitute x equal 3, y equal 1 into here and get what, if you add 1/9 that amount of time, what you would get. An infinite amount of time, what you will get. So we have to move on to number 3 now. So we have a circle with center 1, -1, passes through the point 4, 3, and they want us to calculate the radius of the circle. Well, recall that the formula for a circle, or the equation of a circle, is given by x minus the center point of the x center point squared plus y minus the center point of the y coordinate squared, and that is equal to r squared. So simplifying, we get x minus a, now that is 1 squared, plus y minus 1, that is plus 1, because minus by minus is a positive, or negative by negative is positive, squared equal r squared. Now we want to get a value for r, right? The radius of the circle. I notice the radius of the circle is positive because that, well, it's how it is defined. Right, so when we are ready, we'll just take the positive square root. We will not take the negative square root. And, well, the radius is defined as a distance from the center to any point on the circumference. Distances are not necessarily negatives. All right, displacements are negatives because displacement is a vector quantity. Remember that? So, well, displacement can be negative or positive. Anyhow, so we could substitute these values here, right? Because we know that our circle passes through those points. So we have x equal 4. So we have 4 minus 1 squared plus, we have 3 plus 1 squared equal r squared. So 4 minus 1 is 3. 3 squared is 9. Plus 3 plus 1 is 4. 4 squared is 16. Plus r is equal to r squared. So we get r squared is equal to 25. So finally we get that r is equal to 5. So this is our radius. We have a radius of 5. So write the equation of the circle in this form. Well, rather than trying to guess coefficients and all of that, what we could do is use this formula and expand it and simplify it. So we could use this formula, but we could substitute for r since we know what it is now. All right, so that's just allow me to copy this. And now I could substitute that r is 5. Right, so we could multiply these things out. So we get x squared minus 2x plus 1. Right, so you should have a lot of practice with squaring binomials, plus y squared plus 2y plus 1. And then we could bring across the 25, so you have minus 25, and that is equal to 0. So we can simplify, so we get x squared minus, well, we only have 2x. We want it in this exact form, right? So we have plus y squared. So they want the x term now, so we have minus 2x plus 2y, and we have 1 minus 25 is negative 24, and that is equal to 0. And that is our form that we require. So notice that that is exactly what they have here. Determine the equation of the tangent to the circle at the point 4, 3. So they want the equation of the tangent. So what we want is that, so what we have, let's look at what we have. So we have some circle, right? And our center of our circle is -1, 1, -1. So something like this. 1, -1. Right, so this is 1 here. 1 and -1 here. The point 4, 3 looks something like, so this is like 4, 3 is somewhere here. And this is our tangent to that point. All right, this is our radius to that point. Notice that this angle here is at 90 degrees. So we could get our equation of our radius, right? And then use that is -1 over that radiant and get our tangent equation. So what do we get? We have our radius, if we recall, the 2 points that our radius passes through is this and this. We have our 2 points for our radius. So we can get the gradient of our radius. So I'll just write that as MR. Gradient of the radius would be equal to same y2 minus y1 over x2 minus x1. And what is that? Well, y2 we could use as these values here. So that's 3 minus -1 divided by x2, which is 4 minus 1, positive 1. Right, so we have 4 on the top, 3 in the denominator. So our tangent, so I'll write the gradient of the tangent would be -1 over mr. Why? Because it is perpendicular to r. So we get this as -3/4. Right, we just flip it. So the gradient of our this is the gradient of our tangent, but we want the equation of the tangent. So the equation of the tangent could be found using y minus y1 equal m into x minus x1, this formula of the straight line. So notice what point would we use? We would use this point because the tangent passes through that point. So we have y minus 3 is equal to -3/4 into x minus, well, 4. Simplifying, we have y minus 3 equal -3/4 x plus 3, right? Because negative by negative is positive, and 3/4 by 4, the 4's cancel and give you 3. And we could carry that 3 across. So we get y is equal to -3/4 x, the negative change to positive, so we get plus 6. And this is our equation of our tangent. Part B, two vectors P and Q are such that P equal 8i plus 2j and Q equal I minus 4j. This is the same thing as writing P equal 8, 2 and Q equal 1, -4. Right? Don't let the I and J confuse you too much. So we want to calculate what is P dot Q. So the dot product is coming from just multiplying the corresponding entries and simplifying, or the corresponding vector components. So the x component, we multiply them. So 8 times 1 is 8, plus 2 times -4 is -8. So what is this? This is 0. Now, you should be jumping for joy here. What happens when the dot product is 0? Right? Maybe you could comment below and tell me before I say it. But when the dot product is 0, that means that the vectors are perpendicular. Right? Because if you could recall, P dot Q is equal to length of P, length of Q, cosine theta. And if this is 0, the length of P is not 0 because we know that it is not the 0 vector. So that is some value. Length of Q is not 0 because we know that the Q is also not the 0 vector. So that means the cosine of theta is equal to 0. And remember that that angle goes between 0 and 2 pi. So now the angle we could take as 90 degrees. Right? So the angle between them is 90 degrees. I hope that makes sense. So theta is equal to 90 degrees, or that they are perpendicular. Right, and we want the angle between. So we have the vector 8 plus 2i, that is something like this, 2j, sorry, and then the other one is something like this. Right, so and the angle between them is 90 degrees. Part C, the position vector A equal 4i minus 7j. We want to find a unit vector in the direction of A. So let's call that n hat for unit vector, or u hat. Let's use u hat. That is equal to, now we want it in the direction of A, so we have the vector divided by the magnitude of the vector, and that would be in the direction of A. That would be a vector in the direction of A. Now the magnitude of A, let's just do that at the side here quickly. That is the square root of this term squared, that's 16, plus this term squared, which is 49. And 16 plus 49 is, that is a 5. Is that, okay, that was weird. Sorry about that. All right, so that is not 55. All right, that is 65. And we still have our square root. Okay, now we would allow square roots in the denominator for this because it's just a unit vector. So we have 4i minus 7j divided by the square root 65. Now you can feel free to rationalize on all of that. That's fine, but this is okay for now. Okay, all right, continuing. So that's it for number 3. So we are on to number 4. A compass is used to draw a sector of radius 6 and an area of 11.32 centimeters squared. Determine the angle of the sector in radians. So what I want you to recall is the values of, well, the formula for arc length and the area of a sector. Right, so that's that, you could see that here. Let's see if they gave us it. All right, let's see. Unfortunately, no, they did not. Right, so we have to recall that formula. So let's see what that formula is. So the area of a sector, now the arc length is straightforward. The arc length S, right? The arc length S is equal to r theta, right? Where the angle there is in radians. The area of a sector is now, recall that the area of a circle is pi r squared. All right, now that is for the area of the circle. Now suppose we want, sorry, suppose we have the angle, or we want the area of the portion of the circle. Well, that would be, this is the area of this full circle. That would be some angle over 360 times pi r squared. Now we want our angle in radians, right? So that is what we need. So what we want is this 360, instead of being in 360, we want it in to be 2 pi. All right, so we could cancel off these 2 pi's. So we have the area of the sector, or the area of the region. Now this is still a general formula. It will be a half theta r squared. All right, and now notice if you substitute theta being 2 pi, you'll regain this formula here. Cool. So we have our area of our sector and our arc length. So determine the angle in radians. That is this thing here. This is already in radians. Right, so we have the area being 11.32 cm squared. We don't need to put that right now. That is equal to a half theta r squared. Now we know that r is 6 centimeters. We are given that. So we have 11.32. Now we can multiply both sides by 2. So let's do that right away. So we have 22.64 is equal to theta times 36, right? Because r squared, we have 6 sixes are 36. We can divide by 36. So we have the angle is equal to 22.64 divided by 36. And that we could use we could use 2 decimal places. So we have 0.63 radians. Okay, lovely. So they want us to calculate the perimeter of the sector. So that's something like this. So we have our angle here in radians. Right? And we have our sector of the circle doing that. Cool. So notice the perimeter of our sector is the whole distance around, not just the arc length. So we have the first thing we have to do is calculate our arc length, because we know that this is 6 and this is 6, because those are radii. So the perimeter is equal to 12, because 6 plus 6 plus 6 times our angle, because we are using the arc length formula here now. 6 times our angle in radians, so that is 0.63. So the perimeter is equal to 12 plus, now 0.63 by 6, it is 3.78. So what we get finally is 15.78 centimeters. I hope that was clear. Part B, a right-angled triangle XYZ has angle theta, where sine of theta is square root of 5 over 5. Without evaluating theta, calculate the exact value in third form, if applicable, of cosine theta. So if we have our right-angled triangle, all right, let's get it like that. All right, let's put it right here. This is our right angle here. This is our theta. Now we know sine of theta is opposite over hypotenuse. So the easiest triangle we could get is square root of 5 being here and 5 being here. All right, so sine of that theta would be square root of 5 over 5. So what is this remaining side? Well, we could use Pythagoras theorem to get that out. All right, Pythagoras theorem. Or you can go about doing it the long way. Either way is fine. So by Pythagoras theorem, we get this squared plus this squared should be equal to that squared. So we have root 5 squared plus, let's call it x squared. This should be equal to 25. Right, because 5 squared is 25. We have 5 plus x squared equal 25. Carry the 5, etc. So we get x is equal to 20. So x squared is equal to 20. And we take square root. So we assuming that it is positive, right? Because we could assume that we are in the first quadrant or whatnot, right? Because of how we orient the triangle. Right? And usually when we are dealing with these types of triangles, we deal with it in the first quadrant, unless stated otherwise. So we have square root 20. So we have x is equal to the square root of 20, which of course could be written as square root of 4 square root of 5, which is 2 root 5. All right, so we have this side of our triangle. is, let's just bring these things down. This side here is 2 times the square root of 5. So cosine theta. So cosine theta is equal to the adjacent side, which is 2 root 5, divided by the hypotenuse, which is 5. Which of course you would notice that is 2 sine theta, not sine 2 theta, that is 2 sine theta. Cool. So now they want what is sine 2 theta. So recall that sine 2 theta is equal to 2 sine theta cosine theta. And we already know what is sine theta. We are given that. That is root 5 over 5. So we have 2 root 5 over 5 times 2 root 5 over 5, because that is what cosine theta is equal to. So we have 2 times 2, that is 4, times 5 by root 5 by root 5, that is 5. And 5 by 5 is 25. So we have everything divided by 25. Simplifying, that's 1, that's 5. So that is equal to 4. So sine 2 theta is equal to 4/5. And notice we did not need to evaluate theta. Part C. Show that tan squared plus 1. So tan squared of theta plus 1 is equal to 1 over cosine squared. So some of you may know this as sec squared or secant squared of x, but they want it in this starting. So consider tan squared theta plus 1. Right, so we want to consider that side and work towards the next side. Now, what is tan? Tan is sine over cosine. So we have this is equal to sine squared theta over cosine squared theta, and we still plus 1. Right, so we can get a common denominator. So we can get everything. So sine squared theta. Now everything is over cosine theta, or cosine squared of theta. And now 1 could just be written as cosine squared of theta over cosine squared of theta. Or you could say this is like 1 over 1. 1 into cosine squared theta is cosine squared theta. So 1 times cosine squared theta is cosine squared theta. And you will notice that this is the fundamental theorem of trigonometry. Sine squared theta plus cosine squared theta, or cosine squared theta plus sine squared theta, that is exactly equal to 1. So we have 1 over cosine squared theta. And that is our proof. So we have left hand side is equal to the right hand side. So we are done with our proof. And we are moving on to number 5. All right, so the stationary points of a curve are given by 5, 11 and 2/3 and 3, 15. Derive an expression for dy dx. Now we have the points of a curve. Now how do we derive an expression for dy dx? All right, this is our stationary points. This is where dy dx is equal to 0. dy dx is equal to 0 at these points. All right, and what we need in particular is the 5 and the 3. Right, not so much the y values yet. All right, so we have dy dx is equal. Now we could use that as factorization, right? Because that's where we have it equal to 0 as x minus 5 times x minus 3. So if we substitute x equal 5 there, we get 0. And if we substitute x equal 3 there, we get 0. So this is our expression for dy dx. In fact, we could even multiply it out if you wish. So we have, oh, you can notice that this is x squared. We have minus 5x minus 3, that's minus 8x. And we have plus 15. All right, so this is dy dx. So they want us to determine the nature of the stationary points, like maximum, minimum, etc. All right, so let's verify that. So one way of verifying it is by using tables. What I prefer to do is take the second derivative, and if that is positive, then it is a local minimum. If it is negative, then it is a local maximum. All right, so let's differentiate this once again. So we have dy dx, or d2y dx squared, the second derivative, is equal to 2x minus 8. And we can substitute these points, the x values, to get what the values are for d2y dx squared. So if we substitute 5, so at x equal 5, we have d2y dx squared equal 10 minus 8, which is 2. And 2 is bigger than 0, with that meaning that it is positive. That means that we have a minimum at x equal 5. And finally, if we substitute x equal 3, so at x equal 3, d2y dx squared is equal to, that's 6 minus 8, and that is equal to negative 2. And of course, that is less than 0, and that implies a maximum at x equal 3. And it can look at the points as well. Right? If you look at these points, this is clearly lower than that one, right? The y values. So you may be tempted. So a lot of people forget what these things mean. So if we have a positive values minimum, it's kind of counterintuitive until you see the proof, which is of course at a higher level. All right, but you could always use the points to kind of verify what you're thinking is. So we have a maximum at x equal 3 and a minimum at x equal 5. Determine the equation of the curve. So what they want here is the integrate. We want to integrate what we have. So remember, dy dx is equal to x squared minus 8x plus 15. So if we were to integrate this to get back our equation of our curve, we will get y equal the integral x squared minus 8x plus 15 dx. That's after we integrate here. So integrating, we get x cubed over 3 minus 8, that is 4x squared, because we added 1 to the power and divided by the new power, plus 15x, and then we have plus some constant of integration. Now what do we, how do we get that constant of integration? Well, we could use one of these points up here. We know that these are the stationary points on the curve, so that we know that the curve passes through those points. I would prefer to use the second point, as it is not as complicated as the first point. I don't like to work with fractions too much. So we could substitute x equal 3 and y equal 15. So if x is equal to 3 and y equal 15, we have 15. X equal 3, 3 cubed is 27. 27 divided by 3 is 9. Minus 3 squared is 9. 9 fours are 36. Plus 15 threes are 45. And that's plus c here. So simplifying, we have 15 is equal to, now 36, negative 36 plus 45, that is 9. 9 and 9 is 18. And then you can check that 9 minus 36, that is what, 28. And then, all right, let's just make sure that I didn't make any arithmetic errors here. Right, no, that is exactly 18. Let's take it, verify that, plus c. And then we could solve for what c is. So we get that c is equal to -3. Right, so our y is equal to x cubed over 3 minus 4x squared plus 15x minus 3. And that is our equation of our cube. Right, and you would see if you perform the find the stationary points, etc., you'll see that those are the exact stationary points. Part B, differentiate the cube root of 2x plus 3 all squared with respect to x, given your answer in its simplest form. All right, so notice that we could write the cube root as the 1/3 power. So we have 2x plus 3 squared, and all of that is raised to the 1/3 power. So we can multiply the powers. So we have 2x plus 3 to the 2/3. And we can differentiate this by using the chain rule, differentiate it as normal, and then multiply by the derivative of the inside. So let's say that this is y. So dy dx is equal to 2/3 times 2x plus 3. And now remember, we have to subtract 1 from the power. So we have minus 1/3. And that's times the derivative of the inside, which is 2. Right, so simplifying that, we get 4 over 3. Now, this negative 1/3 power, you could put it in the denominator and write it as a cube root. Right, now this is fine. Right, after you multiply it and simplify, you could leave it as a negative exponent. But why would I want to write it as a cube root is because I have it here in my original expression. So we could carry that in the denominator. So we'll have the positive exponent. So you have the cube root. So 3 times the cube root of 2x plus 3. And that's our answer. Let's just write that a little bit more nicely. So we have 4 times 3 times the cube root, 4 over 3 times the cube root of 2x plus 3. Number 6, integrate 3 cosine x plus 2 sine x. So if we integrate, so we have integral 3 cosine x plus 2 sine x dx. Now the thing is with this level, I don't like. They tell us integrate, but they did not tell us with respect to what. So we'd have to assume that is the that is with respect to x, but that is not necessarily the case. Right? Anyhow, let's continue. So integrating that, we get 3 sine x, because the integral of cosine is sine. Right? And 3 is just a constant multiple. We can pull that out the integral. And the integral of sine x is minus cosine x. So we have minus 2 cosine x. I think that's what I said. Right, and that's it. But we have to remember to put our constant of integration. So we have plus c. Part B, evaluate the integral from 1 to 4 of 2 times the square root of x over x. Now notice, the square root of x is like x to the 1/2 power. And if we divide by x, we could use exponentials to simplify this to get x to the minus 1/2 power, or yeah, we can leave it like this. All right, and you would see why just now. So we have the integral from 1 to 4 of 2 times x to the minus 1/2 power for the reasons that we had here, dx. So we can take out the 2 or the integral. So we have 1 to 4 of x to the 1/2 dx. So recall the rule, add 1 to the power, divide by the new power. So, sorry, minus 1/2 here. So we have 2. What do we get? If we add 1 to negative 1/2, we get positive 1/2. So we get x to the positive 1/2. And divide by the new power, we get to divide by 1/2. All right, and that's evaluating from 1 to 4. Now dividing by 1/2 is the same as multiplying by 2. And we can multiply by the 2 outside. So we get 4 into 4 to the 1/2 power, upper limit minus lower limit. So 1 to the 1/2 power. Now 1/2 is just the same as taking the square root, right? 1/2 power. So the square root of 4, that is 2. So we have 4 times 2 minus the square root of 1 is 1. So we have 4 times 2 minus 1 is 1. So that is just equal to 4 times 1, which is 4. Lovely. Part C, the point 2, 4 lies on the curve whose gradient is given by dy dx equal negative 2x plus 1. Determine the equation of the curve. So similarly to what we did before, we want to integrate this and use the point to find the constant of integration. So we have y is equal to negative 2x plus 1 dx, right? And we are integrating that. So what do we get? We get negative 2. Well, right, if we add 1 to the x power and divide by a new power, we get negative x squared. All right, so we get 2x squared over 2, and the 2's cancel. And we have the integral of 1 dx is just x. This is our equation here, and then we have our plus c. So this is our integral. Now we are told that when x is equal to 2, y is equal to 4. So we have 4 is equal to negative 4, well, negative 4, because 2 squared is 4, and we have the negative out front, plus 2 plus c. So we have 4 is equal to negative 2 plus c. So c is equal to 6. Right, like this, carrying that across. So our equation of our curve is given by y is equal to negative x squared plus x plus 6. The area under the curve, so they want to get the area under the curve in the finite region in the first quadrant between 0 and 3 on the x-axis. So that is equal, so the area under the curve is equal to the integral. Notice that we want between 0 and 3, so we're going from 0 to 3. Right, of our equation here, which is minus x squared plus x plus 6, and then of course dx. I don't know if you want to draw a sketch. Right, notice that we have a local maximum because x is because a is negative, right? So and then we want to go from 0 and 3, so that's this area here, right? This is just a rough sketch. This isn't by no way correct, maybe, right? It's just a sketch to show you an illustration. So integrating this, what do we get? We get to add 1 to this power, divide by a new power, so we get negative x cubed over 3 plus add 1 to this power, divide by a new power, x squared over 2. Add 1 to this power, divide by the new power, we get, well, 6x, right? Because 6x over 1 is still 6x. Evaluate that from 0 to 3. So I wanted to notice if we plug 0 in here, we get 0 throughout. And that is, well, that will not contribute anything. So all we need to do is just add to the top. Well, apply the upper limit. All right, now notice if we had an extra constant term here, the 0 would have mattered. Right, or a trigonometric function like cosine, that would have mattered. But since all of them have an x here and we put 0, we'll just get 0. So if we put 3 in, x cubed over 3, right? So 3 cubes is 27, divided by 3 is 9, so we have negative 9 plus 3 squared is 9, that's 9 over 2, and 6 3s are 18. All right, so that's just 9 plus 9 halves. Right, and you could write that as 27 halves. All right, or 9 and 9 halves, or you can simplify it further. Cool. So this is the area under the curve. So part 4. Now they ask us to answer only one question, but we'll see if we can answer both. All right, so number 7. The weights in kilograms of students in grade 5 class are displayed on the following stem and leaf diagram. So on the boys side, we have 8 line 2 means 28 kilograms. So 8 line 2 is 28. And on the girl side, 2 line 8 means 28. So 2 line 8 is 28. All right, so what I want, or what I did, was calculate the X bar values, which is the average values. And by using this, you can calculate standard deviation, etc. Right? But what I did was go ahead and do certain parts of these questions because it is a little bit of time, a little too much time consuming. So let's get into it. Say the number of students in the class, where we simply count up everything. And notice that we have 15 boys, 14 girls. So that is 29 students. Right? 15 boys and 14 girls. 29 students. Construct one box and whisker plot for the entire grade of 25. Grade 5 class. All we did was use the data given above. And I forgot to write in. Let's say 4 line 0 means 40. All right, this is the key. All right, and I hope this makes sense. So like, let's do 28, the first line with y'all. So 2, 9, 8, notice that we have 2 on one side and 1 on this side. So we need 3 here. All right. And then we have 1 on this side, 1 on that side. So we have 2 here. All right, and that's what we do to fill out the stem name. Finally, the standard deviation of the weights of the boys is 5.53. Determine the standard deviation of the weights of the girls. Provide an interpretation for your answer. So notice we could use any one of these formulae here to find the standard deviation. I will not be doing it in this video, unfortunately, because again, time consuming, but I will explain how to do it and I will give the answer. I used this equation here, the last one. And what does that mean? Well, the average, if you notice here, I worked out the average here and that happened to be 35.4. And what would that mean? Well, I add up 28 plus 28 plus 29, etc. and then divide by 14. And I get my 35.4. That is my average weight or average, weight, average mass. All right, I say mass because kilogram is a unit of mass. So we have the average. So we have, this is one part of our equation that we need. We know that n is 14 and xi is each value. So we do 28 minus that and square it plus 28 minus that square it, 29 minus that square it, etc. That is what the sum of the squares of the individual differences mean. All right, and then we add up all those things, and then we take the square root after we divide by the 14. All right, and when you do that, what do we get? We get 4.83. So the standard deviation, or S, right, we're using S, is 4.83 kilograms. And that is the standard deviation of the girls. Now, what does this mean? Well, recall that standard deviation gives a spread of the data. So the higher the standard deviation, the more spread out your data is. So we could say that the girls, standard deviation right now, they tell us to compare it to that of the boys. So we can say the girls' standard deviation is less than that of the boys. Than that of the boys. Hence, the boys' data is a lot more spread than the girls. Right, so that means the girls' data are much more close to each other than that of the boys. And you'll notice that most of them are in the kind of 30 to 40 kilogram weight, whereas the boys that have a lot in the 30s, a lot in the 40s, it even have 50s and in the 20s. Right, so the boys' data are a lot more spread out. And they only have one more person, so that didn't really do much. So determine the number of students above the 20th percentile. So above the 20th percentile. So if we recall how to do these things, the 20th percentile is found by, well, 20% is like 0.2, 0.2. And if we multiply this by the number of things from the class, number of elements, or in this case, students, the number of students is 29. Right, and we could approximate that to be around 6. All right, so because 0.2 by 29 is about 5.8, but we could approximate that to be 6. All right, so we have 6 students. After the 6 students, that is where the 20th percentile is. So we could count the first 6. So we have 3 and 3 is 6. So this here is my 20th percentile. So they want how much students is above that. All right, how much students is above that? So the 7th student is what we use as our 20th percentile. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, so we have 22 students above our 20th percentile. So therefore, we have 22 students above 20th percentile. Part B. A vendor has 15 apples on a tray. We have 5 red, 6 green, and 4 yellow. A customer requests 3 apples but does not specify the color. So we need to choose 3 apples. And they want us to determine the probability that the apple chosen contains one of each color. So that means it could be, now they didn't say they want exactly a red, yellow, or green in that order. So we have to consider all the orders. So I would have done this by using a tree diagram, right? So if we use a tree diagram, let's construct it at the side here. Let's allow me. So we have our choices. So the first choice, it could be a red, could be a yellow, or it could be a green. All right, so if I chose red, now this is my first choice. Here, this line is my first choice. Then I have 3 choices again. So we have red, green, oh sorry, red, yellow, green, that's what we're doing. And here we have the same red, yellow, green. All right, and then red, yellow, green. So this is my first choice. This is my second choice. And my third choice is red, yellow, green, red, yellow, green. So red, yellow, green, red, yellow, green. Sorry, I forgot this one. Red, yellow, green, etc. Right. So I hope that this kind of makes sense to some of you, but the space is a little bit constricted. So it may have been best to draw it a little larger. right? But let's go through what we have. So now they want one of each color. So it have one that if we choose red, then we have to choose yellow, and then after that we choose green. All right, then we have the probability of choosing red, then green, then yellow, etc. So we have to have the permutations. And how much permutations we have? We have 6 possible permutations, such that each of them is a different color. So the probability is equal to, now it is chosen without replacement. So the first choice is like red, then yellow, then green. So let's just write it out. So probability that we get red, yellow, green, plus the probability we get red, green, yellow, plus the probability we get we could say yellow, red, green, plus the probability we get yellow, green, red, plus the probability we get, well, now we can put green in front, green, sorry, yeah, probability we get green, red, yellow, and finally the probability we get green, yellow, red. Right, and I believe that is our permutation. That is our possible ways. All right, so in this one, I would let's write what we get. So this is the probability. Now, how much reds do we have? We have the probability that we choose red at random first, that is 5 over 15 times the probability that we choose a green is 6 over 14. Why? Because we already take a red apple or 1 apple out. So we have 14 apples remaining, but we still have 6 greens. All right, and finally, the probability of choosing a yellow, that is 4 times 13 plus, so that's our first one. The second one, the probability that we choose a red, that is 5 over 15 times 6, not 6, sorry, 4 over 14 times 6 over 13. Now, what I want you to realize here is that all of these possibilities are equally likely because we are multiplying them and the order of multiplication doesn't matter. So this is why I kind of shortcut the top here so that we could spend a little time on this. I know this gives a lot of people trouble. So what I could do to save time is notice that all of them are equally likely. So I could say that the probability is just 6 times, because I have 6 permutations, of 5 by 6 by 4 divided by 15 by 14 by 13. Right, because I could just interchange these two here and it will give me the same value. So what is this? This is equal to, now for 15 by 14 by 13, that is 2730, and 5 by 6 by 4, 5 6s 30, by 4 is 120, and by 6 is 720. Right, and that is our probability of getting one of each colors. And if you want that as a decimal, right, so 720 divided by 2730, that is about 0.264, if you wish. Right, so you have a 26.4 chance of getting one of each color. Now they want that all are the same color. So we want 3 to choose 3 of them, but all are the same color. Now this is not necessarily equally likely, right? So how we could have done this here, and in this example, we cannot do that because we have the probability is equal to the probability of choosing all red plus the probability of choosing all green plus the probability of choosing all yellow. Right, so how does this work? Well, the probability of choosing the first one red is like 5/15 times, right? Because we have 5 red, 4/14, because we already take out 1 and we have 4 reds remaining, times 3/13. So that's our first one. Plus, now we put back everything and we want to choose all green. So how much greens do we have? We have 6 greens. So we have 6/15 times 5/14 times 4/13, plus we put back all and we want to do yellows now. So we have 4 yellows. So we have 4/15 plus 3/14, sorry, not plus, times 3/14 times 2/13. And we know that 15 times 14 times 13 is all, that's 27, 30. So 5 times 4 times 3, that is 60, plus, right, because 5 4s are 20, 23s are 60. 6 5s are 30, that's 120 here, plus, let's just make sure we didn't make any errors. 6 5 times 4. Okay. Right, and finally, 4 times 3 times 2, that is 8 times 3, that's 24. When you find that, probability that they get all the same color, 60 plus 120 plus 24, that is 204 divided by 2730. And what is that as a decimal? Well, that is about 0.073, sorry, 75. Right, so you have about 7.5% chance of getting all the same color. But they didn't specify which color. They just say all are the same color. Now, if they say that all was red, then you'd have just done this piece. If they say only green, that would have been this piece, or only yellow, that would have been this piece. But since they say they didn't really specify a color, you have to add the states. Lovely. So I think we are on the last question. Yes. So let's just do this quickly. So number 8, a car has stopped at a traffic light. When the light turns green, it accelerates uniformly to a speed of 28 meters per second in 15 seconds. The car continues to travel at this speed for another 35 seconds before it has to stop in 10 seconds later at another traffic light. On the grid provided on page 25, draw a speed time graph showing the information above. Okay. Well, you are usually to use as much graph page as possible, but just for this purpose, I would just do it here quickly. All right, so we have 0 time. All right, we can start here and say this is our time axis. They say they want a speed time graph. All right, a speed time graph. So speed is on the x, and let's just use this piece here. Speed is on the y, of course, in meters per second, and this here is in seconds. Lovely. So we have our maximum speed was 28 meters per second. Right, so that's our highest speed. Let's see if we could find a nice value for that. Right, so I could say 28 meters per second is right here. I don't notice I could have used more graph, but instead of scrolling up and down all the time, let's just use this piece. In your exams, please use as much as the graph page as possible. Put in a scale, title, etc. So I could say graph showing speed time graph. All right, and my specific scale was, yours would be different. I have If 7 centimeters is 28, that means 1 centimeter is equal to 4 meters per second on the y-axis. Right, and on the x-axis, well, we can do that now. At the time, now he took 10 seconds to stop. Now it may be in our best interest to put 5-second intervals. Right, 5-second intervals, let's see. So we have, if every one is 5, I mean every 2 is 10. So we could kind of space that out, 10, 20, 30, 40, 50, 60, 70, etc. So I could say now 1 cm is equal to 5 seconds. That's on my x-axis. Right, so let's plot out our graph. So what we have the first one. It took 15 seconds to reach the top speed, and we accelerated uniformly. So that means we have constant acceleration. So the point 1528 is here. So let's use a different color. Let's use blue. So that's right here. Then they continued at that speed for 35 seconds. Right, 35 seconds. So 35 and 15, that is 50. So at 50 seconds, it was at that speed. And it took how long to come back to rest? It has to stop in 10 seconds. So 10 seconds later, it has to stop. So 10 and 50, that's here. So drawing these, what do we get? So we started at rest. Accelerated uniformly. And we came to rest in 10 seconds. Right, and that's our graph, our speed time graph. So let's see what the question asks us here now. Calculate the distance the car traveled between the 2 traffic lights. Well, the distance on a speed time graph is the area underneath our graph. And this is the area of a trapezium, right? A half AB by the height, or you could split it up into a triangle, rectangle, triangle. Right, so the distance is the area underneath here. So we have a half AB. Notice that this distance here is 35. This distance underneath here is 60. And our perpendicular height is 28. Right, our height is 28. So we have 35. So I have 35 plus 60 times 28. So the distance, right, let's go back to black, is equal to a half 35 plus 60 times 28. Can simplify that. So that's 14. So we have 35 plus 60 is 95 plus, sorry, times 14. And what is 95 times 14? Right, let's look at that. 95 times 14 is 1,330 meters. Calculate the average speed of the car over this journey, given your answer in kilometers per hour. All right, so firstly, we can calculate the average speed. So the average speed is equal to the total distance, which is 1330, over the total time taken, which is 60 seconds. All right, everything takes 60 seconds to happen. So what we get is that our average speed is given by, well, is approximately, I should say, let's say 22.17 meters per second. And we want kilometers per hour. How do we get kilometers per hour? Well, to go from meters to kilometers, we divide by 1,000. So we have, all right, so it's like 22.17, all right, meters in 1 second. So that's our average speed here. Right, so we want to convert this to meters, so we divide by 1,000. Right, so you can say that that is 0.02217 meters. And how do we go from seconds to hours? Well, we divide by 3,600. So we have 1 in 3,600 hours. Right, why 3,600? Because it has 3,600 seconds in an hour. Right, so divided by 1 over 3,600 is the same as multiplying by 3,600. So if you multiply this here by 3,600, we get the speed, the average speed, to be 79.81 kilometers per hour. Right, and that's our average speed in kilometers per hour. Now part B, which is the last part, tells us a particle moves in a straight line such that t seconds after passing a fixed origin O, or fixed point O, its acceleration a in meters per second squared is given by a equal 12t minus 17. So that's our acceleration. Given that its speed is 10 meters per second at the origin, determine the values for t for which the particle is stationary. So firstly, we could get what v is. Remember that a is equal to dv dt. Right, the rate of change of velocity is acceleration. So that means we could get our velocity by just integrating this. So we have the velocity is equal to the acceleration is given by this equation. Notice if the acceleration were constant, we will get at here plus some constant, but we do not have constant acceleration. So we have the integral of 12t minus 17 dt. Integrating that, we get, well, t squared over 2. So we get 6t squared, right? Because 12 over 2 is 6, minus 17t plus some constant of integration. And we are told at time equals 0. Now, our origin is where the time equals 0. So t seconds after passing the origin. So that means after it passes the origin, we start timing. So that at time equals 0, v is 10. So at t equals 0, v equals 10. So we have 10 is equal to 6 zeros are 0, 17 zeros are 0. So we just end up with c. So c is 10. So the velocity is given by 6t squared minus 17t plus 10. Now they want to know where the particle is stationary. That means that the velocity is 0. So all we need to do is find the stationary points. That means to differentiate it and set it equal to 0. Or sorry, my bad. Stationary. That means that we are not moving. So that means v is 0. So they want the roots of this equation. Right? They want the roots of this equation. So we have 6t squared minus 17t plus 10 equals 0. Right, so you can go about factoring this, or let's see if it is factorable. 6 tens are 60, factors of 60 added to give us 17. Maybe it is factorable, or maybe you could just use the quadratic formula. T is equal to minus b, which is minus 17, plus, sorry, positive 17, plus or minus square root 17 squared, which is 289, minus 4ac, right, that is 6 by 40, and 6 fours 24, so that is 240 here, divided by 2 times a, which is 12. So t is equal to 17 plus or minus, right? So we have 289 minus 40, All right, 240. What is that? That is 49. So square root 49 divided by 12. So we have t is equal to 17 plus or minus. Now the square root of 49 is 7 over 12. All right, and we can get the two values. So t1 is 17 plus 7 over 12. And 17 plus 7 is 24. 24 divided by 12 is 2. So t1 is 2. Or we have 17 minus 7 over 12. So t2, that is 10 over 12. And 10 over 12 is around, so t is approximately t2. That is 0.83. All right, so at these two times, the particles are stationary. Now notice that this was clearly factorable, right? Because of the perfect square under the square root there, that was factorable, but it would have taken a bit longer to find the sum of roots, product of roots, etc. Cool. So the distance the particles travel in the 4th second, so that's the final thing. So we want to find distance. So now distance, remember that velocity is rate of change of distance, or in this particular example, so dt normally is the rate of change of displacement, but here we could use them interchangeably. So the displacement is the integral of v dt. And what is v? V was given right here. So dx is equal to integral 6t squared minus 17t plus 10. And we have dt. Integrating this, right? So if we integrate dx, we get x only. Right? Integrating this, we get 3t cubed. Sorry, 2t cubed. Divided by 3. 6 divided by 3 is 2. Minus 17 over 2t squared plus 10t plus some constant. And we could use maybe one of these equations here. Well, one of these points here to get what the origin, well, at the origin, the displacement is 0 and the time is 0, right? Because we did not check any distances there. We did not know how far the particle come from, and we started timing at the origin. So at t equals 0, x equals 0. So we have 0 is equal to, but this is 0, 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 this is 0. So therefore c is equal to 0 as well. So we can just ignore it. And we want in the 4th second. All right, in the 4th second, that means we just put t equal 4. So we have x in the 4th second, that is 2 by 4 cubed minus 17 over 2 by 4 plus 10 by 4. And what is this? All right, well, we could simplify it. This is like 1, that's 2. 4 cubed is 64 by 2, that is 128, plus minus 17 by 2. 17 by 2, that is 34, and then plus 40. Right, so 34 plus 40, that is 6. 6 and 128. Right, 6 and 128 is 134. And of course, this is in meters. Right, so 124 meters. That is what in the 4th second it travels 124 meters. And that is it. So I want to thank you all for tuning in, and hopefully I could get 2 or 3 more of these papers out before Wednesday. So I'll see you all in the next video. Thanks.